Hi everyone, we are solving this physics paper today. This is 9702, paper 1-2 from the May June 2024 series, and the time is 1 hour 15 minutes. I'll slowly be rolling out all the papers for the May June 2024 series for physics, chemistry, and math. I'll be doing physics paper 1, 2, 4, and 5. Okay, so there are 40 questions in total, and the total mark for this paper is 40. Okay. So let's take a look at the threshold before we begin. But before that, I'd just like to give a quick shout out to my Patreon. If you guys like my content, please remember to hit the subscribe button and like my video. It helps with the algorithm a lot. Also, if you think you need more help and like my content, you can consider supporting me on Patreon. It's patreon.com/CAIE-papersolved. I'll drop a link in the description. So here, yeah, basically you get access to 3 tiers you can choose from here. The first one is for general support. The second one, the highlighted tier, is the most popular one, where you get access to one-on-one problem solving sessions over text. And you get access to all my solved papers for physics, chemistry, math, and bio. For science, it's paper 1, 2, 4, and 5. And for math, it's P1, P3, M1, and S1 from 2002 to 2023. And 2024 will be included as well, the ones I solve. Also, you get access to the same videos that are on YouTube, but they are ad free on Patreon. Plus, yeah, you get to drop in requests for question paper solving for my next YouTube videos. And for the ultimate learning experience, the highest tier, you actually get access to all the same perks, plus one-on-one video meetings with me once or twice a month, where we can solve your personal problems, plus a shout out at the end of every video. Anyway, let's take a look at the threshold. So for this paper, let's see, component 1, 2, A was at 30, okay, B was at 26, C at 22, D at 19, and E at 15. So yeah, comparatively this was the hardest paper out of the 3. Okay, so let's just write that down. So A was at 30, then B was at 26, C was at 22, D was at 19, and E was at 15. So A star, as you can see, the gap is like 3 to 4 marks, so it should be 3 or 4 marks above. So A star is at 33 or 34. So if you get this mark, you are getting that A star. Okay, so let's actually start. Let's not waste any more time. Okay, starting with question 1. What is a scalar quantity? We know that a scalar quantity only has magnitude, right? A scalar quantity only has magnitude. Okay, so no, a quantity that does not require a unit. Quantities need a value and a unit, so B is wrong. A quantity, it should be with a magnitude. A quantity with a magnitude but without a direction. Yes, so 1C is correct. A quantity that can be represented as 2 perpendicular components? No, that is actually a vector quantity, right? Next to the value of x has percentage uncertainty of 2%, and the value of y has percentage uncertainty of 4%. The value of a quantity w is calculated from the values of x and y. The value of w has a percentage uncertainty of 8. What could be the relation? So when 2 of them are multiplied or divided, we just add up the percentage uncertainty. So for A, it will be x times y, which is 2 plus 4, 6%. So A is wrong. 2 times x times y. Any constants are ignored. So it's still 2 plus 4, which is 6%. B is wrong. Now let's go for W. So multiplication, division, we add percentage uncertainties. But whenever there's a square, what happens is, it's basically this C is x divided by y into y. So we need to consider y twice because there's a square. Okay, so it's basically 2 plus 4 times 2, or 2 plus 4 plus 4, which is 2 plus 8, which is 10%. So C is also wrong. But for D, it's going to be 4 plus 2 into 2, which is 4 plus 4 or 8%, which is why D is the answer. Number 3, a football kicks so that it moves vertically upwards through the air. What is the variation in the air resistance and the resultant force acting on the ball as it moves vertically upwards? So the ball is moving upwards. So as you can see, as it goes up, velocity decreases. So as velocity decreases, we know that air resistance will decrease, because the higher the velocity, higher the resistance. So air resistance decreases. Next, what about the resultant force? So here's the thing. What is the force acting on the ball right now? So it always has weight acting on it. It has weight acting on it downwards, and since it's going up, air resistance always opposes motion, so it also has air resistance acting on it downwards. So air resistance plus weight, that's the resultant force. However, we know that over time weight remains constant, but air resistance, the value of air resistance decreases. So since this decreases, the value of resultant force will also decrease. So answer is 3A. That's the logic. Which statement is not correct? Acceleration can be determined from the gradient of a velocity time graph. That is totally correct. Gradient of a velocity time graph is acceleration. It is the rate of change of velocity. That is also correct. Displacement can be determined from the area of a velocity time graph. So the gradient of a displacement time graph is velocity. So the integration, since the differentiation of displacement against time is velocity, so the integration or the area under the curve of the velocity time graph will be displacement. So C is also correct. Velocity is the rate of change of distance. No, it is the rate of change of displacement. Oh, this is a common question. Number 5, I've seen this. The diagram shows a laboratory experiment in which a feather falls from rest in a long evacuated vertical tube of length L. The feather takes time t to fall from the top to the bottom of the tube. How far does the feather fall from the top of the tube in time? 0.5 seconds. Okay, 0.5 t. Okay, so evacuated, so no air resistance, acceleration is constant. We can write s is equal to ut plus half at square. So total length L is equal to 0 plus half into a into t square, or L is equal to half at square. Fine. Next we want to find out the distance. Then we go again. S is equal to ut plus half at square. So S is equal to 0 plus, let's make A the subject. So A will be 2L by t square. So half into 2L by t square times the time, which is 0.5 t whole square. So S is equal to, can get rid of these, L by t square times 0.25 t square. So we can get rid of this again, because 0.5 square is 0.25. So we ultimately end up with S is equal to 0.25 L. Okay, that's good. So we get 5B. Okay guys, I'm gonna be rolling out more content, at least 1 or 2 videos weekly. So please comment below what kind of videos you want. Do you want more of math, more of physics, more of chemistry, or more of biology? Whatever you want. And which paper you want more, like paper 1, 2, 4, or 5 from science, and for math, P1, P3, M1, or S1. A car travels along a straight horizontal road. The graph shows the variation of the velocity v of the car with time t for 6 seconds of its journey. By the way guys, I've been playing Black Myth Wukong and it's such an amazing game. It's so good. I'm almost done with it. I'm at the end of chapter 4. You guys should definitely play it. It's so good. A car travels along a straight horizontal road. The graph shows the variation of the velocity v of the car with time t for 6 seconds of its journey. The brakes of the car are applied from t1 to 4. How far does the car travel while the brakes are applied? Okay, so the area under the velocity time graph is the displacement. So over here it is 22, and over here it's 8, and yeah, the height is 3. So the area of the trapezium is going to be half into a plus b into height. So half into a plus b is 22 plus 8 times the height is 3 seconds. So it's 30 times 3 by 2. 15 times 3 is 45. So 6 should be B. 7. Two satellites in deep space collide inelastically. So momentum conserved, but kinetic energy is not conserved. Momentum will always be conserved, but kinetic energy is not conserved. Since it's inelastic, Ke will not be conserved and it will be reduced. What is a reasonable estimate of the momentum of a family car traveling at 25 kilometers per hour? Okay, this is an estimate. So momentum, P is equal to m times v. So mass, it should be about 1 ton, which is 1 kg. It's an estimate. And 25 kilometers per hour in meters per second is 25 times 1000 meters by 3600 seconds. Let's try doing this. What do we get? 25 times 1000 by 3600 into 1000. So I'm getting 6944. So what is the closest to this? It's around 7000 basically. So this is 1000 and this is 10,000. So yeah, the closest one to this. Let's try to figure this out. Kilograms, meters per second. Sorry, I made a mistake. My bad. This one is 1 into 10 power 4, which is 10000 zeros. 100,000, right? So I got 7000, but I forgot to take the mass of the passengers, okay, into account. So maybe with the passengers, the mass would have been like 70 times 4, which is 1280. 1280. 4 passengers. So 1280 times 25 times 1000 by 3600. It's like 8888. So yeah, the closest one to this is 10,000. So 8 is basically A. A ball collides with a wall. Before the collision, the ball moves with velocity 8 meters per second to the right. Okay. After the collision, it moves with a velocity of 3 meters per second to the left. What is the change in the velocity? So basically, the change, final, minus 3, minus initial, plus 8. So the total change is actually minus 3, minus 8, which is minus 11. So actually, minus 11 or 11 meters per second to the left, as you can see, because they mentioned the directions over here. Okay. Oh, this is also a common question. A lead pellet is shot vertical upwards into a clay block that is stationary at the moment of impact but is able to rise freely after impact. The mass of the pellet is 5 grams and the mass of the clay block is 95 grams. The pellet hits the block with an initial vertical velocity of 200 meters per second. It embeds itself in the block and does not emerge. So it embeds itself. So it becomes stationary. How high above its initial position will the block rise? Okay, so at first we need to apply momentum. Okay, so basically this is what happens. 200 times 5 initial momentum plus 0 is equal to final momentum. The total mass becomes 100 grams times final velocity. So 200 times 5 divided by 100. So the final velocity will be 10 meters per second. So after it gets embedded inside, kind of like this, after it gets embedded inside, it will move with a velocity of 10 meters per second, but gravity is acting, so it will stop in a bit. Okay, so it will stop in a bit. How high above its initial position will the block rise? So It has Ke. This Ke will be converted to Gp. So half mv square will be converted to mgh. We can get rid of the mass. So half into 10 square is equal to 9.81 into h. 0.5 into 10 square divided by 9.81. That gives us an answer of 5.097 or 5.1 meters to be exact. So 10 is A. Two forces act on an object, which diagram represents a couple. So essentially, what is a couple? The answer is B. It is a pair of forces of equal magnitude acting in opposite direction but providing the same type of moment. So it has to be equal magnitude but acting in opposite directions and providing the same type of moment, which is anti-clockwise in this case. 12. The diagram shows a uniform rod xy that is freely hinged to a vertical wall at end y. The rod is at an angle of 60 degrees to the wall. The force F acts at an angle of 30 degrees to the rod at the end x. At end x, the rod has weight 3 and is in equilibrium. So net moment or net force is basically 0. So what is the magnitude of force F? So I don't know the force acting at y. So I can't consider total force. I'm going to consider total moment, considering this as the hinge. Okay. Let's see how we can do this. Okay, so F has a component like this. This is basically F sine 30. This is 60 degrees. And the weight has a component like this. This is 60 degrees, right? So this force is actually weight 3 sine 60. Okay. Now something else that you need to know, the total length. The total length is L. So this length over here will be L by 2. So since it's in equilibrium, net moment 0, net force 0. So net moment, we can write F sine 30 times L is equal to, that is the clockwise moment, and this is the anti-clockwise moment, right? So 3 sine 60 times L by 2. We can get rid of L. So 3 sine 60, I need it in degrees, wait. 3 sine 60 into 0.5 divided by sine 30. So I'm getting F is equal to 3 root 3 by 2, which is 2.598 or 2.6 essentially. So yeah, 2.6. We are right. 13. Water has a density of 1 gram per cm cube. Glycerin has a density of 1.3 grams per cm cube. A student measures out a volume of 40 cm cube of glycerin into a container. The student adds water to the container to make a mixture of water and glycerin. Assume that the total volume of water and glycerin does not change. Which volume of water needs to be added to make a mixture of density 1.1? Okay. So density of 1.1. So essentially, we added 40 cm cube of glucose out of the total proportion of volume, which I don't know, times 1.3. So this is the general formula. The proportion of the volume of glycerin times the density of glycerin plus the proportion of volume of water divided by the total volume times the density of water 1.0 will give us the total volume. So will give us the total density. So see if this makes sense. The net or the total density will be equal to the proportion of the volume of a particular liquid times its density and the summation of those. So this is for glycerin and this is for water. So I can break this down further. 1.1 is equal to 40 divided by 40 plus V times 1.3. plus, sorry, let's call it W, the volume of water, plus W divided by 40 plus W times 1.0. So 1.1 is equal to, what is 40 times 1.3? 52. 52 divided by 40 plus W plus W divided by 40 plus W, or 1.1 is equal to 52 plus W divided by 40 plus W. 40 times 1.1, that is 44. 44 plus 1.1 W is equal to 52 plus W. So we have 0.1 W is equal to 52 minus 44, which is 8. We get 80. I'm getting 80. So let's check 80 cm cube. And yes, the correct answer is 13D. Next, the force resisting the motion of a car is proportional to the square of the car's speed. So the force resisting motion is proportional to the square of the car's speed. The magnitude of the force at a speed of 20 meters per second is 800. Okay. What useful power output? Output power is required from the car's engine to maintain a steady speed of 40. So this is a constant, right? So we can actually write 800 divided by 20 square is equal to the force at a speed of 40, resistive force at a speed of 40, it should be 40 square. So 800 by 20 square times 40 square. So we're getting a value of 3200 newtons. This is the resistive force at 40 meters per second. Now we're maintaining a steady speed, we're maintaining this. So the forward force is equal to the backward force. So we know that P is equal to Fv, and the driving force will be equal to the resistive force of 3200, which is 128000 watts, or 128 kilowatts. So 14 is in fact C. Next, 15. A box of weight is pulled by a force P along a slope. The length of the slope is D and the box rises a height H. The frictional force between the box and the slope is F. The diagram shows the direction of the forces. The purpose of the slope is to raise the box vertically, which expression gives the efficiency of the slope. So we are basically getting mgh or wh. This is useful. This is the useful power. Efficiency is useful power divided by total power input. So what is the total power input, or the total work done? Work done is equal to force into distance. Work done is equal to force into distance. So here the useful power is mgh or wh, and the total input is force P times distance, which is PD. So the correct answer is D. That was the input power. Some of it was lost as friction, but the useful power was only the gain in GP. The kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increase? So we know that Ke is equal to half mv square. Half and m, these are constants. So Ke is proportional to v square. So when does Ke increase by a factor 4? Factor 4. What happens to velocity? If you square velocity, like velocity will always be squared, right? So check this. If you double velocity, 2v whole square is basically 4. Or you could do it this way. Check this. We know that K is proportional to v square. So v is proportional to root over K. So since K became 4 times and root 4, that is actually equal to 2. So velocity increased by a factor of 2. Next, a mass of 28 grams is raised vertically upwards through a distance of 4.6 meters. What is the change in GPE? vertically upwards. So it's mgh. So mass in kg, 28 into 10 to the power minus 3 times 9.81 times 4.6. So 28 times 10 to the power minus 3 times 9.81 times 4.6, that gives us a value of 1.26 or 1.3. 17 should be B. Next, 18. A sample of metal is subjected to a force which increases to a maximum value and then decreases back to 0. A force extension graph for the sample is shown. When the sample contracts, it follows the same force extension graph. So what does that mean? It has not become plastic yet. It is not plastic yet. It is still elastic, because if you have the ability to return to the original position, that means you are elastic. So it is elastic but not plastic yet, because if it was plastic, then it would return like something like this. The length would have become like it would have been elongated compared to the original length. Yeah. Two wires P and Q made of the same material are stretched with an increasing force. A graph is plotted of the variation with force of the extension of each wire. The wires have the same original length but different diameters. What is the ratio of this? So we know that the Young modulus is equal to FL by AE, or Young modulus is equal to FL by pi d square by 4 into E, or it's 4 FL by pi d square E. So we need to find out the diameter. Yeah. So wait, let me do this. So if we make diameter the subject, d square is equal to 4, sorry, this should be a small e for extension. So 4 FL divided by pi Young modulus and extension, or d is equal to root over that. Okay, so I'm going to find out the ratio now of diameter Q by diameter P. So root over 4 FL by pi Young modulus E, root over 4 FL by pi Young modulus extension. Now let's just input things. So the force is the same at 2 newtons and 4 is a constant. They have the same original length. Pi is also a constant. They are made of the same material, so they have the same Young modulus. So let's get rid of the root over. It makes things complicated. So let me make things simpler for you guys. dq by dp whole square is equal to 1 by extension of q divided by 1 by extension of p. So if you do the reciprocal, dq by dp is actually equal to ep by eq and root over the whole thing. So look at the extension, ep by eq. So it's actually 3 by 1. So root 3 by 1. So what is that? How much is that? Do we have that as an option? Root 3. Root 3 by 1. So 19 is actually C. Yeah, we're correct. Next, 20. An extension force graph is shown. What is the spring constant? We know that F is equal to Kx. So K is equal to F by X. Always remember F by X. So F by X. 6 divided by 0.15 in meters. So 6 by 0.15, that is 40. So 20 is actually D. I'm correct. A man stands stationary in front of a swing. A child sits and swings. The child blows a whistle that emits a sound at a constant frequency. The man observes the frequency of the sound when the swing is at positions X and Y. When will the man hear the highest frequency? So this is basically the Doppler effect. A phenomenon where the apparent frequency has changed compared to the original frequency due to movement of the source relative to the observer. This guy is the observer and this guy is the source, the child. So at points X and Z, the child will momentarily be at rest. So at that time, no Doppler effect will occur. Doppler effect occurs the best. The change in frequency will be the highest when you have highest velocity. So it is not x or z because the child will be stationary, no Doppler effect. It will be at y. But now it depends when the child is coming towards the man or going away from him. So the logic is, if you go towards the observer, frequency increases. If you go away from the observer, frequency decreases. So we want highest frequency. So the child should be going towards the observer. Okay. So when the swing is at y and moving towards the man, which is y21 is C. Hopefully that makes sense. Next, a loudspeaker is playing music in a room. The door to the room is open and has a width of 0.8 meters. Sound waves of many different frequencies pass through the doorway and diffract. The speed of sound in air is 340 meters per second. What frequency of sound wave diffracts the most as it passes through the doorway? Okay. So we know that V is equal to F lambda. Okay. So this is trial and error. I'll tell you why. So see this. For A, 340 is equal to 2.4 into 10 power minus 3 times lambda. 340 divided by 2.4 into 10 to the power minus 3. So lambda is 1.4 times 10 to the power 4 meters. Next, 340 is equal to 8 into 10 power minus 1 times lambda. 425. Still too high. Next, 340 is equal to 2.7 into 10 power 2 times lambda. 2.7 into 10 power 2. So lambda is 1.26 meters. Close. Next, 340 is equal to 4.3 into 10 power 2 times lambda. 4.3 times 10 to the power 2, 0.79 meters. So the golden rule is, the closer the wavelength to the width of the gap, the better the diffraction, which is why the answer is D. And quick trick for you guys, always try in trial and error questions, go for the last option first, because it tends to be the correct answer. Okay, that's just a trick from chemistry, physics and bio. Okay. So for 23, a stationary sound wave is set up between a loudspeaker and a wall. A microphone is connected to a cathode ray oscilloscope and is moved along a line directly between the loudspeaker and the wall. So we have a loudspeaker here, wall here. And we are actually moving a microphone in between these. The amplitude of the trace from the CRO rises to a maximum maximum at point X, falls to a minimum, and then rises once again to a maximum at position Y. The distance between X and Y is 33 centimeters. Okay, max at X, max at Y, and distance is 33. So X, Y, this distance is 33. And these are antinodes. Okay, these are antinodes. Okay. So we know that the distance from one antinode to the other is actually lambda by 2. So 33 is actually equal to lambda by 2. So lambda is actually equal to 66 centimeters. That's the wavelength. All right. So we know that the speed of sound is 330 meters per second. So let's see. So let's check. So time period, we can find a 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 0.5, 8 centimeters times 0.5 is 4 milliseconds. That's the time period. So we know that frequency is 1 by time period. and V is equal to F lambda. So 330 is equal to 1 divided by 4 into 10 to the power minus 3. Or, you know what? Let's just do it this way. I can just do this. V is equal to F lambda. So 330 is equal to frequency times the wavelength, which is 0.66 meters. So 330 divided by 0.66, that gives us 500 hertz. So time period will be 1 by 500, which is 2 into 10 to the power minus 3 seconds, or 2 milliseconds. Time period is 2 milliseconds. So I just need to find out 2 milliseconds. Okay, so let's say this 4 boxes, so 4 times 0.5 ms, that is 2 milliseconds. So yeah, I guess we have our answer. So 23 looks like it's B. Okay, good. 24. Polarization is associated with certain waves. It is associated with transverse waves, okay, not longitudinal. So we know that sound is a longitudinal wave, so it cannot be polarized. 25. A guitar string is plucked. Which statement describes the resulting wave? So basically, a guitar string is plucked. So if you pluck it, this is what you see in the guitar string. So as you can see, on the string, it's a transverse wave, because energy is transmitted in this direction, and we know that according to the definition of a transverse wave, the vibration or direction of oscillation is perpendicular to the direction of energy transfer. So on the string we have a transverse wave. Okay, on the string there's a transverse wave, but since sound is being produced, it's a longitudinal wave in the air. So 25 is actually C. 26. A diffraction grating with n lines per meter is used to diffract light of various wavelengths lambda. The graph shows the relation between the diffraction angle theta and lambda. Okay, so we know that d sine theta is equal to n lambda. So sine theta by lambda is equal to n by d. So we know that there's a relationship between capital N and d. D is equal to 1 by n. Okay. Sorry, this should be n by d, yeah? So d is equal to 1 by n. So let's do that. Sine theta by lambda is equal to n divided by 1 by n, or it's just n times capital N. So this is the gradient of the graph. Sine theta by lambda is equal to n times capital N. So 26 is A. 27. A stationary sound wave is formed in the air column inside a tube that is open at both ends. The stationary wave has 3 nodes. Okay, so at the open end it will be an antinode. So one node, another node, another node, and there you go. So here you go, node, 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 antinode here, antinode here, antinode here, antinode here. How many antinodes does it have? 1, 2, 3, 4. So it has 4 antinodes in total. 27 is D. Interference fringes of separation X are observed on a screen at a distance of 1 meter from a double slit that is illuminated by yellow light of wavelength 600 nanometers. At which distance from the double slit would interference fringes of the same separation X be observed when using blue light of wavelength 400 nanometers? Okay, so we know that X equals to lambda d by A. So we need the same separation. So X is equal to distance d, that is 1 meter, lambda is 600 nanometer, and this said nothing about the slit width, but this has to match. Okay, X has to match. Blue light of 400 nanometers. Distance d of the screen is unknown, but we are using the same slit width because they mentioned nothing about that. Same apparatus. Okay, so d will actually be equal to 600 by 400, which is basically 6 by 4 or 1.50 meters. Yeah, 28 is d. I just equated X. I considered it to be a constant. Okay. 29. What is the definition of potential difference across a component? So we know that V is equal to work done per unit charge. So it's the work done or energy transferred per unit charge. That is the definition we're going to be looking for. V equals to work done by charge. Work done is energy transferred. 30. The diagram shows a cell of negligible internal resistance connected to a switch and two resistors of resistances R and 2R. The circuit also contains two ammeters. The reading on X is 4 amperes when the switch is open. Okay. What are the readings on X and Y after the switch is closed? So 4 amps. You can consider this to be V. Or let's just consider a random value. Like maybe 8 volts, okay? So we know that or yeah, maybe this is 2 ohms, okay? So we know that V is equal to IR, no internal resistance, okay? They mentioned that. So the potential difference of the battery is 4 times 2, which is 8 volts. Now what happens? After we close this switch, fine. So this is still 8 volts. However, it's a parallel circuit now. 1 by R plus 1 by 2R reciprocal. Two by 3R, but both of them will be getting 8 volts. Okay, 8 volts, 8 volts. But the total resistance is 2 by 3R. But I don't need to do it in terms of R because I considered this to be 2 ohms, right? I can consider this to be double, which is 4. So basically, yeah, you could do it this way, but it will be complicated. Rather than that, an easier way to do this is just considering my value. It's 1 by 2 plus 1 by 4. So that is basically 4, 2 plus 1, which is 4 by 3 basically. 4 by 3 ohms. Okay. So to find out this current, the total current in the circuit, V is equal to IR. I is equal to 8 divided by 4 by 3. 8 divided by 4 by 3, that gives us an answer of 6 amperes. So this is 6 amperes. And to get this current reading, we know that V is equal to IR, and this is going to be getting 8, right? And this is 4 ohms. So I is equal to 8 by 4, which is 2 amps. 2 amps. Okay. So A is going to be 6 now, and X is going to be 6 now, and Y is going to be 2. So we're looking for 6 and 2 on 30. So yeah, that is the correct answer. Hopefully that makes sense, okay? And this was initially 0. Now the IV characteristics of 4 components are shown. Which component has the greatest resistance when potential difference across it is V? So we know that V is equal to IR, R is equal to V by I. So it's the gradient of a V by I graph. But guys, this is actually the I by V graph. So what you need to consider is we are looking for greatest resistance. So R is equal to V by I when voltage is V1. Everyone over here has the same voltage value, but look at the current value. The lower the value of the current, since it's V by I, the lower the value of the current, the higher the value of resistance. So since D has the least voltage out of these 4, D should have the highest resistance for the same voltage, 31D. Next, a cylindrical wire has cross-section area A and number of density of free electrons is N. We know that I is equal to NaVq. A second cylindrical wire has cross-section area 0.5, number density is 2n. In this wire, the free electrons have an average drift speed of 2v. Where is the current in the second wire? Okay. So number density 2n, area 0.5, drift speed 2v, but q will remain the same. So we can get rid of these two. So I is equal to 2NaVq. So it's actually double the current of the initial wire. So 2I. 33. An electric current is formed by moving charge carriers, which is not possible. So we know that charge is quantized. That means it is integer multiples of the elementary charge, 1.6 into 10 to the power minus 19. So this is possible. 4.8 divided by 1.6 in 10 to the power minus 19 is 3. This is not possible because 2.4 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19 is not an integer, it's 1.5, which is false. So 33b is not possible, which is the description of Kirchhoff's first law. So the first law states that the sum of current entering a junction is equal to the sum of current leaving the junction, and it is a conservation of charge actually. Okay, it considers the currents at a junction and is the consequence of the conservation of charge, not energy. Energy relates to the second law. 35. The two resistors of resistance small r and capital R are connected in parallel. Which statement is correct? It is equal to R plus R. No, that is for a series circuit. Okay, so check this. Suppose you have 2 and you have 4. So let's do the math. 1 by 2 plus 1 by 4 reciprocal. 1 by 2 plus 1 by 4 to the power minus 1, which is 4 by 3 or 1.33. Okay, so it is not in between 2 and 4. It is not in between them. Because check, I can do another example. 3, 6. 1 by 3 plus 1 by 6 reciprocal. 1 by 3 plus 1 by 6 and reciprocal, that is 2. So look, where is 2? 2 is less than the smaller value. Then 1.33 is less than the smaller value. It will always be less than the smaller value. Okay? 35D. The diagram shows 4 identical resistors connected in a circuit. Which resistor dissipates the most power? Okay. Are they identical? Yes. So we know that power dissipated is equal to I square R. So they all have the same resistance. But who has the highest current? A. Because here current is not split into two parts yet. So it has the highest current and it will dissipate the most power logically. So answer is A. Now moving on to radioactivity. Nuclide X with proton number Z undergoes beta plus decay. So we know that in beta plus decay, what happens? Suppose this is 14, 6. So a beta plus particle has a mass of 0 but a charge of 1. We get an electron neutrino, and the mass number remains the same. However, the proton number decreases by 1. So proton number of Y is actually minus 1 compared to before. And the particle that we get is a neutrino. In beta minus decay, we get an antineutrino. Which fundamental particles form a hadron? So quarks make up hadrons, right? Quarks. Hadrons and baryons are made up of quarks. Baryons and mesons, basically, they're hadrons. The unstable nuclide decays through a sequence of emissions of alpha and beta minus to form the stable nuclide of this. Okay, so let's try. 218x84. So let's go. Alpha decay 42, we get A. So this is 21482, and then again we get B. Again alpha decay, we get 80. Now we need to increase the proton number by 3. So what will happen? 81, this is beta minus decay, and so on. This will keep on happening again. D 210, 82, And finally again the third time, 0 minus 1 beta minus decay, 210, and we finally get y. So we need 2 alpha particles and 3 beta minus particles. Okay, so that is my answer. 39 is C. Which statement about radioactive decay is constant? Neutrinos are always emitted during alpha decay. This is wrong. They are always emitted during beta plus decay. The alpha particle emitted from a radioactive sample have a continuous range of kinetic energies. No, this actually applies to beta plus and beta minus particles. The beta minus particles emitted from a radioactive sample have a continuous range of kinetic energies. This is correct. D. The proton number of a nucleus decreases by 4 when it undergoes alpha decay. No, it decreases by 2. That is the correct statement, okay? So guys, that is it for the day. Overall, I thought it was a very easy paper, honestly speaking. I don't think it deserved, like 30 was okay. I think 30 was okay for it. And yeah, you should be, if you're a very good student or a better than average student, you should be able to get 33 or 34. So if I made any mistakes, please do point it out in the comment section. If you have any queries, please do comment it down below. And please be sure to, comment down below any requests for question paper solving that you have. I'll be more frequent with releases. Anyway, that has been it. If you liked the video, remember to subscribe to the channel. Helps with the algorithm a lot. And I'll drop a link for my Patreon. If you need more help, you can just subscribe there. I'll be there to help you guys. So I'll drop the link for May-June 2024 paper 1-1 up here, and the link for May-June 2024 paper 1-3 down here, and the playlist for physics paper 1 will be up here. And remember to hit the subscribe button. Bye bye guys, see you, take care.